Hello friends, my name is Jonathan. In the following video we are going to try on the one of the methods to solve the n-queens problem. For the people we know well about this problem deals with the ways in the which n-queens can be placed on a chessboard of n-sides without attacking each other. Among the algorithms that seek to solve this problem are the genetic algorithms, which appeared in the early 60s in an investigation carried out a student on the Coruña University. It is clearly explained that algorithms are inspired by the field of nature. These are based on mechanics of natural selections and natural genetics. Another of the techniques and we will implement is the backtracking. This technique is more commonly known as recoil technique and that seeks among the different alternatives to correct solution. Smith Ramirez in this research defines this technique as a general algorithm represented by search tree where he has tags and these in turn subtags until he reaches a solution.
Now I will be showing you how our program works. Here we have the main file. We first ask what the size of n will be. The size of n means how many queens we want to place on the board. And then we have our vector, two vectors, our one list of queens, input queens, and our output solution. Then we call our method solve queen, which is very simple. We're not using any recursive methods. We declare our row and column, our possible placement of a queen, and then we just have a while loop. While it keeps looping over this as long as the size of our list is different from n. Whenever we reach, let's say for example our input n was 8, and whenever we reach the size of the list is 8, and then the loop just ends and returns the solution. And here we just have an if statement asking if it's not on the same column and if it's not on the same diagonal, and if the column is less than n, because we don't want solutions getting past greater dimensions than the matrix. And if this returns true, we set the column and we set the row, and we just push it back on the vector and step over to the next row, and we just reset the column variable to 0 so we can start from the left to right. If this returns false, we ask to see if we have reached either the end of the matrix. That means we must use backtracking to get another position from the last queen. And if this returns true, we say we get the last element from the vector and we added 1, so because we want to go to the next position. The same goes with the row. We stay on the same row and then we just delete the last element. And if this returns false, we just keep adding the column, and this will return our solution. And then we just print the matrix. It's asking what's the size of n. Let's just say the size of n will be 8, and that's our solution. You can check, and the queens, no other queens attack each other, so it's a possible solution. Let's try it with a different size of n, let's say 12, and that's our solution. We can also try with bigger values of n, let's say 25. It will take a bit longer, but it returns a solution to placing 25 queens in the board.